guys, Assalamualaikum and good morning. So welcome to CAE. Today we're gonna have a training which is a 2 days program. So currently I have attendance sheet. So please sign the attendance sheet. So for this morning session, I will do some introduction, and before that, I just display here a training course outline. So my name is Mazrun. So just for you guys, you can call me Mazrun. So I actually, a little bit about myself. I've been working with CAE for 12 years, and before this I've been with Malaysian Institute of Aviation Technology, Unica. So my background is more on B1 mechanical. So I've been taking you guys for this program, also teaching mechanical. I joined CAE in 2010, but before that I was in Unica for around 10 years. I was a technician over there, and I was also become promoted as instructor in 2008. So that time was after I got my license. Then I joined CAE in 2010. That time was known as Asia Academy. Then once I joined the Asia Academy, after several years, CAE took over, and the Asia Academy now become CAE. Right. That's a little bit introduction about myself. Let's take a look at the course outline for today. Before that, you guys any question? Any question about me, about myself? Any question? All good? Alright. Let's take a look at the course outline. For today's session, we're gonna have Airbus 320 power plant, CFM56 5B engine. So this will give you, this training is actually to give you system overview on how the engine, the operation of the engine on 320. So you're gonna have a basic knowledge about the engine, and then you may apply this knowledge during your work session. So here in this training, we shall cover general familiarization course. So we are going to look at the general information about this engine, and then we got the course outline written here. At the end of the session, the participant will be able to apply required knowledge and also competency to carry out the task in a safety manner. And then another outline here, the outcome. At the end of this training, the participant able to understand the general understanding of the engine system. Okay. And then the duration is actually 2 hours. Here is written 1 day because the requirement for 1 day's program. And then these are the course content. The course content, we're gonna have introduction, and then we're gonna have the content or the topic which going to cover general, and also engine description and operation, And the last topic will be the recap and any question and answers. And then we're gonna have a training schedule. So since this is a two hours program, we're gonna have we're gonna arrange the timing according to the layout to this training schedule. So we're gonna have introduction. So that will be around 30 minutes. After this, we're gonna have maybe 15-minute breaks. So that's 30 minutes. And then we're gonna go to module 2, which is the content. This would cover the engine general, and also we're gonna cover topic of description and operation. So this is about 60 minutes. So after 60 minutes, during this time, if you guys require question and answers, and also you may require maybe a 5-minute break, you can ask me to do so. And then the last topic will be I'm going to cover recap, and I'm going to cover question and answers. Okay. So that is the course layout, course outline for today's program. We shall then go through the safety briefing, because this is the requirement for CAE. The requirement for CAE, because you are attending our program in our facilities, it is good to know the safety briefing. It is good to know what you need to do in case anything happen around CAE, and it also good for you to know our facilities, because in case anything happen, you guys might have an idea what to do. Right, so over here, welcome to CAE. The safety is our priority. So CAE Kuala Lumpur needs everyone full cooperation and also commitment to practice safety in CAE Kuala Lumpur. So since you guys are first time attending training in our facilities, do you guys know where the emergency exit? Here, know where the emergency exit. So this is very important. Sometimes you guys, since you guys first time, you guys not really sure where the emergency exit, and to me it's something that's very important. In case anything happen, you know where to go. So here is the CAE Kuala Lumpur emergency evacuation plan. Currently we have a layout, CAE layout, where we have facilities. This is the our office layout, showing you a ground floor, and here is the north building, and the other side here is the south building. So you can see here south wing and north wing. The entrance that you came just now is somewhere here, and then we got two lobbies, which is north lobbies and also middle lobby. At the south wing, we got another one more lobbies at the entrance. And then, as my question just now, where's the exit? So the exit here, you can exit through lobbies, and there is another escape route or exit area near to the cafeteria. And looking at the facilities, we have for the north wing is mainly for training session for simulators, and where the south wing, where the location of our classroom, which is on the second floor or the south wing. So be aware that the exit area, north lobby, middle lobby, and south lobby, we also have a staircase. We got one at the north lobby, we got two, we got another staircase here, number 4, 5, and 6. So in case we are, if in case you are sitting in the second lobby, you can use this staircase, which is the nearest, number 4, number 5. So if you exit on if you are using number 5 staircase, this is the shortest route for you to exit the building, as well as number 4 staircase. This is another nearest staircase for you to evacuate. So this layout is showing you ground floor, and there are some other information. For example, like in case of fire, and there is another information regarding fire extinguisher, and here call 911 in case of emergency. And then the most important point for you to know is the assembly point, where it is located at car park B. So car park B, if you, in case anything happen, you exit through the staircase, and then you can walk through to the car park B, where the assembly point is. There is another way where if you use number 5 staircase, you can walk through behind the building, and you are heading towards car park B. So this is the assembly point. In case you are in emergency, we shall gather over here, and we shall collect attendance sheet to make sure that everybody is not in the building. So we have to confirm that everybody is safe during this assembly. And now showing you the facilities for the first floor. So you got the ground floor and first floor. So currently we are at Kuching classroom. So this is Kuching classroom. So you can see that the nearest exit is the number 4 staircase, which is located at the middle lobby. So since we have the CE facilities layout for the first floor, I'm going to show you some other facilities. We do have surau. We do have main office, where you can see in front of our classroom is our main office. There is also showing you a simulator area. Basically, this area is not everybody can access, so you cannot simply go in and out. Within this area, you need to have authorization card in order to access this area.
Excuse me, where is the nearest toilet?
The nearest toilet we do have at the surau here, behind the surau. So from, if our classroom is in Kuching, you can go to the surau, which is towards the end of the building, and the other restroom where you can access through this middle link bridge, and then there is another washroom facilities around here. So basically you got two for the south wing and also for the north wing. For the ground floor, the restroom also will be at the same location. And if I show you the ground floor, The restroom also available in the cafeteria. So very easy. You just minum kopi, and next week there is a restroom. Okay. And here is an example picture for our car park B. This is where the assembly point. So everybody have to gather here. So during emergency, if you hear any emergency sound, you can walk through this to this point. Bear in mind, do not run, but you can walk quickly. Do not run, do not shout, just avoid or to make anything chaos. Just walk quickly to the assembly point. And then if you spot an emergency, so raise the alarm, shout emergency, emergency. So this is something like if you see any potential of a fire, so you need to shout to alert everybody that you are facing a fire or any critical emergency. So in case of fire, so there is a facilities glass outbreak. This is to activate alarm if you see any fire. So you can break this glass and then activate fire alarm. It will tell everybody the building will activate alarm warning. So there is, in case any possibility of fire, so this is what you should do. But do not simply break because there is no fire. You do not simply break because it will activate alarm. Okay. And then if you are facing with fire, it is good for you to try to extinguish the fire to prevent the fire become much more worse. You have to obey. You have to know how to use the fire extinguisher bottle. We got this pull, aim, squeeze, and sweat. So basically, this is the basic principle of how to use fire extinguisher bottle to do firefighting. If you can do so lah. Some people don't know how to use it. They just take the bottle, don't know how to use it, and they throw the bottle into the fire. So do not ever do that. And then we got exit signage. So be alert that there is exit signage in case you are not be able to fight the fire. In case the fire become much more worse, then find the emergency exit and heading to the assembly point, which is, where is it located?
Car park B.
Car park B, thank you. When emergency announced, so let's say if you are hearing any emergency announcement, so evacuate immediately and then use the nearest exit. If you don't know what to do, then the first thing that you need to find is the green exit sign. And then assemble at the assembly point, which is located at car park B, and then report to the incident controller at the command post. Lastly is the safety tips. So basically, the safety tips is a tip for us around here. Do not drive your vehicle fast in this vicinity. Follow the speed limit and observe pedestrian movement. Because we got a lot of people walking around. Do not drive too fast because you have to drive around the facilities in order for you to exit CAE building. We consider it when parking and removing vehicle at the car park, observe any other vehicle or pedestrian movement, use designated walkway while walking to the building and out of the car park area. Another tip is while walking, be alert on the moving vehicle. Maybe you are not aware that a car driving through and you need to cross. So be alert. Do not use your phone all the time while walking. So be alert what's around you. Do not tailgate or jump over using turnstile checking accessway. If you observe any hazard, any potential hazard, you can report using QR code. So basically, QR code is for you to highlight any potential of hazard. Do not read or send message on handphone while walking, especially while using the staircase. Use the water dispenser machine in a hygienic manner. Keep distance of your bottle cup from the outlet machine. So since since we got COVID-19 last time, so this is become something that alert to everybody. Do not use your bottle. The bottle, then the neck of the bottle is attached to the water outlet on this dispenser. So keep it away. This is to maintain our hygiene. Beware of slippery floor, especially during using the restroom. When using a staircase, follow the guideline. Always have one hole on the handrail. Do not use handphone, carriage of baggage, books, and on shoulder or bit in your hand. Have firm footing on the step. Okay, so that's just safety tips. Any questions so far?
No.
Are you guys okay with the facilities? So after this, maybe you can have a look around, and remember the key point is to go to the car park B in case emergency happen. Okay, our topic is chapter 70, power plant. Over here we do have table of content for this session. We're going to cover 2 hours regarding engine general, and in this topic we're going to cover several subtopics, which is component location, engine drains, and also engine power plant. We shall then cover engine description and operation. So over here we're going to have a look at the system overview. So these 2 topics we're going to cover for today's session. Now in this slide presentation, you will be able to see the exploded view of CFM56 engine, and be able to see the fan cowl, and then we able to see the thrust reversal cowl, and we able to see the center body as well as exhaust. Now this engine, the power plant section, is the one that you see, and the engine itself is considered the core. The exploded view of in this picture is the power plant. Another one more forgot to mention is the engine inlet. So all these are the power plant. The power plant section, starting with the thrust reverser cowl. For the 320, the config is using blocker door type of thrust reverser system. So it will activate towards open whenever thrust reverser activated. The fan cowl here, later on we shall see there are 3 latches in order for us to open the fan cowl. So unlock the 3 latches, we able to open the fan cowl left hand side as well as the right hand side. While on the thrust reverser cowl, we got 4 latches. You have to unlatch all 4 latches. Then we need to use external devices, which is the hand pump, to pump out in order to hydraulically open the thrust reverser cowl. Okay, you cannot pull the thrust reverser cowl by your hand because it's quite heavy. But the fan cowl, we can use our own strength. Once you open the 3 latches, using a manpower, we can pull towards open. And then there is a facility for the whole open rod for you to make sure that the fan cowl is keep open, so that you can perform any maintenance tasks around this area. The power plant section also include the center body and exhaust. This is also used to provide facilities of engine breathing, where the engine lubrication system provide breathing and venting through the center body. So sometimes if you perform any maintenance around the engine, if you see any oil, sign of oil behind the center body, then it is considered normal. But if you see any oil puddle, then you might need to do further investigation. So that's the power plant. Let's take a look at the core, where the core of the engine consists of the fan as well as the engine core, and the fan and the core is mounted on the aircraft using a forward mount as well as aft mount. The forward mount is used to take the thrust loop, the engine thrust loop. As the engine move forward, the forward mount is the one that takes the thrust loop and makes that transfer the load to the aircraft. And the aft mount is used to take only the vertical load as well as side load. The thrust load only be taken by forward mount. And then from this picture, we able to see the location of forward mount, the forward mount that attached to the pylon, and then this is the aft mount that provide attachment to the pylon. Okay, shall we move on?
Yes.
Now we got the system overview for the thrust reverser system. Now for the 320 thrust reverser system, 320 employ several defense lines to prevent thrust reverser activation, to prevent thrust reverser activation in flight. The thrust reverser can only activate on ground. Due to accident previously happened on 757, even though different aircraft, but EASA certification require several defense lines for thrust reverser activation during flight. So there was an accident, 757, the thrust reverser deployed during flight. So it becomes scary. It causes the flight characteristic become jeopardized. It caused the aircraft crash. So thrust reverser, before I explain the schematic diagram, let's take a look what do we have. We have thrust lever, we have side computer, spoiler elevator computer, we got EIU, engine interface unit, we got inhibition relay, we got ECU, engine control unit, and then we got HCU, hydraulic control unit, and we able to see all 4 blocker doors located at the C-duct or thrust reverser duct. So the blocker door, this picture shows you the blocker door in deploy position, and it is deployed by the activation of individual actuator. You got 1, 2, 3, and 4 actuators. So it is obviously hydraulic operated. The hydraulic supply may come from engine number 1 coming from green hydraulic system, and engine number 2 may come from the yellow hydraulic system. So since we already identified what what are the components available on the thrust reverser system, let's take a look how does the system work.
Excuse me. Why they use one green, one yellow system? Why cannot use only single system, green for both engine?
Now on this 320, you actually able to deploy one thrust reverser for landing. One thrust reverser activation, there is no problem because on this 320 the engine is located very close to the fuselage, close to each other. One thrust reverser deployed should be no problem. In order to provide redundancy into the system, we got green system that supply to engine number 1, yellow system supply engine number 2. In case green system fail, the other engine also can deploy thrust reverser, also can activate thrust reverser using as redundant system, using a yellow system. Okay. Same goes to in case the yellow system fail, you can use green system. You can only use one thrust reverser, which is on the left hand side at one time, not a problem. You can still the flight crew are still able to steer the aircraft in case only one side of thrust reverser deployed. So it should be no problem. The activation starts with the thrust lever. Once the flight crew move the thrust lever to the reverse thrust, it sends signal to side computer. At the same time, it also sends signal to EID. The side computer, whenever side computer see that the aircraft on ground based on radio altimeter signal, the side computer will then activate hydraulic shut-off. This will allow hydraulic supply to the thrust reverser system, and this is actually breaking the first defense line. So the permission is given by side computer. Once the side computer see aircraft on ground, so it will then give permission. Without hydraulics, you cannot activate thrust reverser. So meaning, aircraft in flight, no hydraulic supply, no thrust reverser in flight. If the permission is only given by the side computer. So we got the first defense line that will break, prevent thrust reverser deployment in flight. Now secondly, the second defense line is via EIU. The engine interface unit, EIU is the one that provides permission to the inhibition relay. We already got thrust lever in reverse thrust. The second defense line, EIU receive signal from LGCIU signal, which is not shown here. LGCIU is the unit that provide information whether the aircraft in flight or on ground. So in case aircraft on ground, the EIU will then provide permission to the inhibition relay. It will activate inhibition relay Once inhibition relay, once you see that this switch make contact, now the ECU has control over thrust reversal system. We shall then see second defense line, first defense line, you got hydraulic, and then you got this relay that provide ECU control over thrust reversal. So both defense line has been break. ECU provide control over thrust reversal by controlling hydraulic control unit. Now the ECU is the one that control hydraulic control unit to allow hydraulic pressure to be supplied to all four actuators. Now the blocker door is in deployed position. Once the blocker door in deployed position, the ECU is then control engine thrust whether to have maximum reverse or minimum reverse. So that's why we can see here the ECU is the one that command hydraulic system to the thrust reversal, whether to open blocker door or extend blocker door or to close the blocker door. Okay, so the blocker door will start to move towards close once the thrust lever move to the forward idle position. Okay, so this is showing you the left engine, which is powered by green. The yellow system on the right engine is also identical. It is the same system. It's just that the hydraulic supply is coming from different source. Okay? Any question? Or question?
No.
Am I, whether I'm done, whether I did a very good job or nobody listening?
Understand.
Okay, so very direct principle. Alright, we shall then move on component identification, component location. The first picture here shows you the ECU, the location of the ECU. We have to aware that the engine for CFM56 series on the right hand side is the component where you can find mostly a dry component, while the left hand side of the engine mostly you will find wet component. So looking on the right hand side, we got ECU, and then this is where it's located. The larger picture we are able to see the ECU, and then we can see the orange ducting is the cooling. Okay, so the cooling is coming from the intake scoop. So this is the orange ducting, the intake scoop. Air may goes in, air may goes out via this open port. So it is used to provide ECU cooling. The ECU is mounted by 4 locking bolt attachment to the engine fan casing, and we got 15 cannon plug located under the engine, under the ECU, and the ECU is actually control the engine by using 2 separate channels. We got channel A and channel B inside the ECU. These 2 channel is housed in one ECU assembly. So the 15 cannon plug is the electrical connection to dedicated channel. 6 of the cannon plug connected to channel A, the other 6 cannon plug connected to channel B. And there are some other connectors which are shared between channel A and channel B. From the same picture, we also able to see the other component, which is the ignition exciter. This is for the system to provide ignition supply, to provide ignition starting. And then at the bottom of the ECU, we able to see the other component which is mounted on the gearbox, which is the PMA, Permanent Magnet Alternator. The PMA is driven by the gearbox. Inside the PMA is actually a mechanical driven alternator, and it has two independent power supply sources. One cannon plug is used to provide power supply for channel A. The other cannon plug is used to provide power supply to channel B. So you can see two cannon plugs. Once engine running and the gearbox also running, same goes to the alternator. Once the alternator running, it provides power supply to the ECU. ECU is no more taking or using any power supply from the aircraft network. Moving further, this is the picture of ignition exciter. We got two boxes. This independent box is provide power supply to ignition A. The other box supply to the ignition B. So we got two igniter plug at the combustor, which is located here. The combustor receives power supply high energy current from the exciter. The ECU that provide command or power supply to the ignition exciter, the ignition exciter will boost up the voltages to give high energy current to the igniter for about 50,000 voltage. And at this location, we are able to see the air starter. The air starter, which is an air-driven starter, which is used to provide initial rotation to the gearbox, which the starter is powered from pneumatic bleed air. Pneumatic bleed air, if we see here, pneumatic bleed air coming from the aircraft bleed air system, which is used to pressurize the ducting, and then it is used to provide starter rotation. We got here inside the starter there is a stator vane that used to turn once the bleed pressure is applying to the starter. So it gives rotational motion to the gearbox. It will then turn the engine, and we can use this to start the engine. The starter will engage right up to 50% N2 of engine speed. More than 50% engine speed, then the starter will be cut off. The control of a starter is achieved by the ECU via the start air valve. So start air valve is the one that allowing bleed pressure to pressurize the starter or disallow the pressure. The start air valve is solenoid operated, controlled by the ECU. So the ECU will look into the engine speed. If we perform engine start, the ECU will control the start air valve. It allows initial rotation until the engine reach 50%. Then the ECU will then close start air valve, because 50% is the speed of the engine that able to reach self-sustaining speed or idle speed. Moving further, another component location, we are looking into the left hand side. Left hand side where this engine equipped with most wet component. Starting off with this location, on the gearbox, we got two components, which is the HMU, hydromechanical unit, and also the fuel pump. The fuel pump is driven by the gearbox. As the name, the pump is used to provide fuel pressure. It is driven by the gearbox, and within this assembly we got two more pumps, which is a high pressure pump and low pressure pump within one housing. At piggyback to the fuel pump, we do have HMU also require an speed input from the fuel pumps in order to govern the engine control system. We shall go further detail in the next lesson regarding the operation of the HMU. But currently, we identified the component located on the gearbox. So this picture shows you the aft face of accessory gearbox. There are many components, many part lines, but the major component we are able to see here, fuel pump and also HMU. Now we move on component location for the engine air system. Now the engine air system, also known as engine control system, which is further being divided into sub-control system. The first part, sub-control system, is the compressor air flow control. The second one is turbine clearance control. Starting with the compressor flow control, there are two main systems that controlling the compressor airflow. The first main system is the variable bleed valve. These are the component location, which is located at the fan area. We got 12 of them. Now this is provide opening and closing in order to condition the air from the fan, from the booster, before it goes to the compressor. So to prevent choking within the compressor module, the bleed valve will open and close in order to condition the air to prevent choking, and this condition is controlled by the ECU. ECU requires several input, and ECU will then provide output by controlling the variable bleed valve. And the other subsystem of compressor flow control is the variable stator vane. So this variable stator vane is actually a system that controlling the position of HP compressor, the vane of HP compressor. So the vane angle can be adjustable. It can be adjusted by using ECU, and the actuator or the system is called variable stator vane. So we got two actuators, left hand side and also right hand side. The ECU will control the vanes in order to increase stall margin, in order to condition the air within the compressor. So it is also used to prevent choking. So by having variable bleed valve and also variable stator vane, it will be able to increase the stall margin of the engine. So we able to increase the efficiency of the engine whenever the engine required to compress the air. So it will help acceleration as well as deceleration. So these two main systems is under compressor flow control. Moving further, turbine clearance control is a system that provides cooling to the turbine component, basically controlling the turbine casing. Now the turbine casing, we know that the operation of the turbine is to extract energy from the gas flow. Combustor, gas flow, the gas flow will turn the turbine, it will extract energy from this gas flow. Extraction of this energy, if we do have turbine blade as well as turbine casing, we can extract more energy by controlling the turbine casing clearance. So this clearance between turbine blade and turbine casing, the clearance, maintaining the gap, is achievable by using cooling air. So the cool air may come from the secondary airflow through here, and we got low pressure turbine active clearance control. So this valve is controlling cold air and provide cooling to the turbine casing. And then another subsystem is the high pressure turbine active clearance control. It is also do the same thing. It provide cooling, control turbine casing expansion to provide a less gap. So whenever you have whenever you have correct clearance between turbine blade and turbine casing, you can extract more energy. So the cooling is achieved by two subsystems: high pressure turbine active clearance control and also low pressure active clearance control. So we already cover turbine clearance control, compressor flow control. Now we have another one more sub control, which is transient bleed valve. Now this transient bleed valve is to provide better acceleration and also de-acceleration over the engine thrust system. Okay, all those three are controlled by the ECU. Next one, looking at the oil component location. This picture shows you the left hand side of the engine, where we got the main component is the oil tank, which is used to house the engine oil. Now the oil system on this engine is a dry sump system. You got the dedicated oil tank separate from the oil system. So the oil tank, and then above the oil tank we got oil quantity transmitter, which is used to provide sensing of the engine oil level. And then we got the oil cap. This is used to provide servicing, and then we do have facilities for inspection. The facilities of this oil side dish, so then the maintenance personnel are able to see the actual quantity inside the oil tank. From this picture, we also able to see the loop unit. The loop unit is a unit that houses high pressure pump and also the scavenge pump. The high pressure pump is driven by accessory gearbox. From this picture, we are unable to see the gearbox. However, at this location, we got a gearbox that used to provide rotational motion to the pump. So the loop unit also consists of oil filter. This is the oil filter housing, which is to prevent contamination over the lubrication system. Next one, we got component location for thrust reverser. Now, the thrust reverser we have here is the hydraulic shut-off valve, which is located at the pylon, can be accessed from the left-hand side. And then we got a component of HCU, hydraulic control unit. This is located in forward flange of the C-duct. We got cannon plug, two cannon plug, and another one more cannon plug for the pressure switch. So this is the one that controlled by the ECU in order to deploy thrust reverser system. So here is the ECU location, and we got hydraulic shut-off valve location. Alright, so that's the component of thrust reverser. Alright, we have done component location. Any question? Good?
No question.
Can you guys remember all the component? Can you guys remember the location of the component?
Some of it.
Some of it, alright.
Yeah.
Alright, basically you got an idea of the component. Later on we shall go further detail on how the system works, the operation. The picture shows you the most best view, which is taken from the manufacturer, where you can see here no engine, but be able to see the location of hydraulic shadow pump. So to me quite okay, but some of the picture are unable to be shown on the slide. But later on we shall go further detail on the system operation.
Can we have a break, sir?
Alright, shall we have a break? Let's take a maybe 5-minute break, and then we continue with next topic, which is the power plant presentation. Okay?
Okay.
Let's have a 5-minute break. Okay guys, so let's continue for the next topic. Before that, any question guys?
Oh, good.
Good.
No.
So we have done component location. Next one we are looking into the distribution and operation. Over here, introduction to description. We got engine model. Now the engine consists of CFM56. These are the model or the variant. And further, we got engine code CFM56. That's 5BX. So 5B is the model that used on the 320, and then X is thrust rating. So it can be numbered from 1 to 9. Later on we shall see the representation of 1 to 9, and basically 1 is covering from 21,000 pound thrust. It can go right up to 33,000 pound thrust. So depending on type of variant that you have, it will give a different engine rating, engine thrust rating. Now, the tag insertion CFM56 5BX. So X, as I mentioned, X is rating from 1 to 9, which shows you the engine thrust. We got /3. /3. Now this is /3. This is one of the variant where /3 means higher efficiency applicable to all thrust rating. The other variant is 5BX/3, or maybe you may have a /P engine. So /P engine, it has higher relight capability. So depending on variant that you have, maybe you have 5BX/3 or /P engine. Now, there's 5BX, X representing number from 1 to 9. So 1, here is an example, and here you got maximum takeoff weight in number, in pound or in kilo. So looking into 5B1, 5B2, 5B3, right up to 5B9. So 5B1 is 30,000 pound thrust. 5B2 also 31. 5B2 is 31,000 pound thrust. 5B3 33, 5B4 27 pound thrust, and you can see the different right up to 5B9. So these are the variant offered by Airbus. For Asia mostly use 5B4 engine, which is 27,000 pound thrust, or maybe the other variant is 5B6, 23,500 pound thrust. And this schedule shows you many more information. For example, like maximum climb thrust, overall pressure ratio, we got bypass ratio, and looking at to the 5B4 is 5.7 to 1 pressure bypass ratio. 5B6 is 5.9 to 1 bypass ratio. So these are shows you different engine variant, and it has a little bit different configuration. Next one, looking into the turbine operation. Similar to other high bypass jet engine, we got the fan which capable to generate 80% of thrust via secondary airflow. So the fan, we got the fan blade and secondary airflow that generate most of the thrust, and we got primary airflow that goes to the core of the engine. This is the air that used for combustion, and only about up to 15% of thrust can be generated at the turbine section. But mainly the primary airflow, it is used to provide rotational or extraction energy from the turbine that used to provide rotation to the fan blade, and the fan is the one that propels the engine to move forward. Starting with the fan. The fan is made from titanium material, and it is consists of 36 blades. And moving further, we got the booster section, which is consists of 5 stages, but the booster alone is 4 stages. And we got VBV, variable bleed valve. This is the one that subs system for compressor flow control, which is used to condition the air before it goes to the high pressure compressor. So the air will pass through the booster section. It will boost up pressure for about 200 or 1 to 200 psi. And then here we got the HPC, which can capable to increase or boost up the pressure up to 600 psi depending on the engine speed. And the HPC, high pressure compressor, consists of 9 stages. The last stages is stage 9. It will boost up the pressure as the air goes into the core of the engine. Here we able to see the component that used to control variable stator vane. The variable stator vane will adjust the angle of the first 5 stages of the stator. This is to increase the stall margin of the engine, so then it able to provide more compression to the engine depending on the engine speed. And then we got combustor. Combustor for this engine, it Airbus offer, or the engine manufacturer offer 2 types of combustor, annular type or dual annular type combustor. In this case, we are able to see this picture shows you single annular type combustor. And we got the single stage of HPT, high pressure turbine. This is used to provide rotational motion to the high pressure compressor by a single shaft. And next one, we got low pressure turbine. So the low pressure turbine is used to extract the energy, and it is used to provide rotation for the low pressure compressor, which is the consists of booster and also the fan blade. Now, you able to see that the low pressure compressor is driven by the low pressure turbine, and high pressure turbine is driving the high pressure compressor. It is a twin spool engine, and we can see the shaft is a coaxial shaft. One shaft for the low pressure shaft is located at the inner, and the outer one is the high pressure shaft. Both of the shafts are rotate clockwise, which reference are looking forward. So both of the shafts rotate at the same direction. The shaft is supported by 5 bearings. We got bearing number 1 located at the most forward, which the bearing number 1 is ball bearing type. And then we got bearing number 2, which is a roller bearing. The bearing number 2, which also used to support the LP shaft. And then the LP shaft also supported by bearing number 5. This bearing number 2 and 5 is a roller type of bearing. The HP shaft is supported by 2 bearings, which is bearing number 3 and also bearing number 4, which is bearing number 3 is a combination bearing, which is also known as ball bearing. We shall see further detail after this. But the 2 bearings that used to support the HP shaft.
Okay. What's the material of the bearing?
The material of bearing is nickel alloy type of bearing, and mostly are the same type of material, but the configuration is maybe different. The configuration for the ball bearing is used to take up the thrust load, but the later stage of bearing is made in the configuration is a roller type of bearing. Okay. Any other question?
No.
Alright. Over here we got bearing configuration. Since we have LP shaft, low pressure shaft, and we got high pressure shaft, as I mentioned, bearing number 1, bearing number 2, and bearing number 5 are used to support the low pressure shaft. So we got 5 bearing, bearing number 1, number 2, and 5 we look for low pressure shaft, and we got bearing number 3 and also bearing number 4 used to support the high pressure shaft. Bearing number 1, 2, and 3 is located in a forward sum, where the sum is used to provide lubrication and house the bearing. So basically this is where the forward sum is. Oil from the oil system lube unit will lubricate all 3 bearings in the forward sum. And then we got aft sum, which is located here. The aft sum, where we can find the location of bearing number 4 and number 5. So aft sum also the same, where it provides lubrication for the bearings. Once the bearing being lubricated, it will then return to the oil tank via a scavenge pump located in the lube unit. So the compartment to house the bearing is divided into 2, which is forward sum as well as aft sum. The detail for the forward bearing, which is bearing number 1, we can see here it is a ball bearing type, while bearing number 2 is a roller bearing, and bearing number 3 is a combination bearing. So it is combination between ball and roller bearing. So ball bearing is used to take up thrust load that coming from the HP shaft, HP compressor, and also high pressure turbine. So all the thrust is taken by the ball bearing type of bearing number 3. And then here is the supporting bearing for the HP shaft, which is a roller bearing. Bearing number 5, which is also a roller bearing. Next one, looking into the air seal. So this is a picture of forward sum where we got the bearing, and in this case we got a pressurizing tube. Now the pressurizing tube is air coming from the booster. By looking at this picture, we will be able to see the pressurizing tube. Pressurized air from the booster is the one that provides sealing to the forward sump. So it prevents the oil from coming out from the sump. It will keep the oil within the sump by using pressurized air. So the air that tries to keep the oil within the sump is governed by the air seal, which is also known as a labyrinth seal, or also known as a knife-edge type of seal. Okay, so the seal is require pressure from the compressor just to keep the oil within the sump. Here is the basic principles, where the bearings, and then here we got the bearing used to support the shaft, and then we got the sump that has 2 compartments. The first compartment where the pressurized air, and the second compartment where the house of the bearing. We know that the bearing is lubricated by pressurized oil, which is coming from the oil jet. Lubricate the bearings. The bearings, once the oil has been lubricated, it will be then scavenged by a scavenge line, and any air bubble will be vented into the core of the shaft, and it will be vented to the exhaust. And then we able to see the sump is sealed by the labyrinth seal. So you can see here the knife-edge type of seal. Here is another knife-edge type of seal. So air that coming from the compressor just now will pressurize the sump, the outer part of the sump, the outer chamber, and the air is trying to push the pressurized air will try to push any oil within the sump from coming out. So air will try to push in, and oil pressure that tends to move outward will be kept within the inner chamber of the sump. So this is how the air is kept within the sump. There is a disadvantage by having this type of seal. The disadvantage is whenever we have unavailable pressure, or whenever pressure is very low to keep the oil from coming out, it will tend to have oil coming out through the labyrinth seal in case we have less pressure. So the pressure has to be proportional to the engine rotation to keep the oil within the sump area. Okay, so that's the basic principle understanding of the oil sealing. Moving to the section where I already explained the forward part of the engine, which is consists of the fan and also booster. So the fan and booster is also known as LPC, low pressure compressor. And the high pressure compressor, which is the HPC section, is consists of the 9 stages high pressure compressor. And then here is the detail for the low pressure compressor, consists of the fan blade and consists of the booster. So we got 5 stages of the booster, where primary air used to provide air for combustion, and secondary air used to propel the engine forward. And the HPC section, as I mentioned, it consists of 9 stages, and then you can see here there is a variable stator vane. So variable stator vane will change the angle of the vane in order to increase the stall margin of the engine. Okay, so here we got a fan frame. These are the strongest area at the fan, and the fan frame here, somewhere here, is used to provide forward mounting facilities. Now, before we move further, here shows you several terminology which regard to the compressor. We got term number 1 known as stall, and term number 2 known as surge. Do you guys know what's the difference between stall and surge? Anybody?
No.
Or can pick a guess?
No.
No idea.
Now, stall means that it is due to the local effect of the blades. In case the blade has distorted or damaged, it can cause stall. So it unable to generate compression at the blade itself. Okay, so it's called stall due to the local effect. The other terms, which is surge. Surge means that whenever all the stages within the compressor section, all the stages are surge, all the stages are stall. So combination of all stages, whenever they become stall, we can call surge. So air that's supposed to be compressed, it may not be able to compress anymore. During engine surge, it can cause fluctuation in speed indication, fluctuation in exhaust gas temperature indication, because the engine is now fluttering. The engine is now unable to compress the air, and it can cause the air to expel in reverse direction. So that is surging. Next one, we move on to the combustor section. Now, combustor, which is located between the HPC and the turbine section, in this case we got a single annular combustor. The combustor consists of 20 fuel nozzles around the combustor itself, and it consists of 2 igniter plugs. So it will provide the gas expansion, and as the gas expands, it will hit the high pressure turbine. The high pressure turbine is then will use to provide rotation to the high pressure compressor. So the flame in the combustor is happen somewhere here, where within the outer liner and also inner liner. So the combustion is here, where the oxygen and also fuel is mixed, and the ignition that being introduced will cause the flame. So this is where the combustion happens, and it is considered as continuous type of combustion, as long as the fuel provide fueling and ignition being provided during initial rotation of the engine, so the flame become continuous combustion, and it will continuously generate gas expansion and then extracted by the turbine section. So this is where the location of the combustor. Now here is the combustor, where the air provide fuel and air mixture, which is here. This is where the fuel coming in, and fuel and air mixture is burned somewhere here. This is the outer liner, this is the inner liner, and you can see that the air also will dilute within the combustor. It will dilute and cooling from the liner. So as the gas expand due to the combustion, it will then the expansion will then deliver to the turbine section. Okay, here is another picture of the fuel nozzle. So this is equipped with 20 fuel nozzles around the combustor. Moving further is the turbine section. Now the turbine section consists of high pressure turbine and also low pressure turbine. Looking at the actual component, this is where the high pressure turbine located. And then the low pressure turbine, which is here, where you can see there are several cooling tubes that used to provide cooling to the turbine casing. So the high pressure turbine consists of single stage, and the low pressure turbine consists of 4 stages. So it extracts energy from the gas that expand. It will then provide rotation to the low pressure shaft, and it will then turn the fan blade. Next one, we able to see a picture of accessory drive. So the accessory drive, what we have here is the gearbox, and here shows you the forward direction. The gearbox is driven by the transfer gearbox. The transfer gearbox is driven by a tower shaft, which is driven from the high pressure compressor. So the high pressure compressor turn the transfer gearbox, it will then turn the high speed gearbox, then the high speed gearbox will then turn the accessory drive. We got the first accessory drive, which is the IDG, integrated drive generator. What is the purpose of IDG? Anybody? Purpose of IDG?
Electrical power to the aircraft.
It is provide electrical power to the aircraft electrical network. Then the IDG is driven by the high-speed gearbox. We shall then see another rotating device, which is the PMA, permanent alternator, permanent magnet alternator. So this rotating device is the component that we see earlier, where it provides power supply to the ECU, which is consists of 2 cannon plug, one for channel A, one for channel B. So we already seen this before. And then we got another rotating device, which is the hydraulic pump. So this is used to provide pressure to the hydraulic system. For green system is engine number 1, and yellow system engine number 2. Another rotating device is the loop unit. So loop unit, the main companion component of this rotating device is the hydraulic pump and also scavenge pump. It provides lubrication to the bearings as well as lubrication to the gearbox. another rotating device which is aft of the gearbox face. We got fuel pumps. Fuel pump here is a two-driven type of pump, which is a low pressure pump and also high pressure pump. And piggyback to the fuel pump is the hydromechanical unit. So this hydromechanical unit is also a rotating device which is used to provide control over engine control system. We will provide control to the all servos actuators. And another rotating device which is the starter itself, which is used to provide initial rotation to the gearbox, and it will then provide initial rotation to the engine. And we can see that all the rotating device attachment to the gearbox is governed by carbon seal. So carbon seal is used to prevent oil leaks between the two component, gearbox and also rotating device. Next one, we got aerodynamic station. So the aerodynamic station is used to identify component at a specific location. We got station 0, which is located in front of the engine. We got station 2, which is located at the engine inlet. We got station 1, 2, also located at the station engine inlet, but at the outer area, outer of the fan. We got station 1, 3, located somewhere here, very near to the frame, and also outlet galvin. We got station 2, 5, which is just before the HPC, and then we got station 3, where the outlet of high pressure compressor. We got station 49.5. 49.5 where we can find a device known as EGT sensors or exhaust gas temperature sensors. And then we got station 5 located at the last stage of high and low pressure turbine. So this station number is also used to identify component as well as location. You may find some other sensors known as T25, for example, which is located here. If you heard about sensors known as T3 or P3, which is measuring temperature at station number 3, which is located here. If you find sensor known as PS3, which is a sensor known identified as pressure sensor located at station number 3. So the station number also can be used to identify location of the sensor. Next one, we have borescope plug, borescope pod. So the borescope pod consists of 23 pod. We got pod A and pod B located at the fan area. These pods are unplugged, there is no plug. In order for you to access borescope or inspection of the internal of the engine, you don't have to remove any plug at this location. And then we got another borescope plug located around 5 o'clock position. This is to facilitate inspection for the HPC, and these are identified, these plugs are identified as SO3 right up to SO9. Sorry, SO1 right up to SO9. So we can find the details in the EMM reference. And then we got combustor. In order to perform borescope or inspection in the combustor area, there is a facilities of 4 pod. And the pod is also include the igniter port. Igniter plug. So we got two igniter plug located at this location. Sorry, it doesn't show here. Igniter plug located at this location, which is not shown in the combustor. But igniter plug, which is two of them, also can be used to provide boroscope inspection. Now this one is not igniter port, but this one is to provide facilities inspection of the later stage of the turbine section. And then here, the later stage of turbine section can also be used by another port, which is located around 4 block position. Okay, so there are some of the boroscope port not shown here, but these are the facilities given by the manufacturer in order for us to perform internal core of inspection. Okay, and we have done the basic description and operation. Any question, guys? Hope you guys understand the description and operation about the engine. These are the basic principles. If you have any question, feel free to ask. Okay?
Okay,
Good.
good.
Alright guys, so we have come to the end. Before that, let's do some recap on what we have learned. Basically, we already gone through general introduction about the engine. We already gone through component location, and we also already gone through description and operation. Now, let's do some recap. The one that we already got through. The power plant section. So the power plant section where it's using blocker door type of thrust reverser. Okay, and then we got latches, 3 latches, not shown here, but to secure the fan cowl, it requires 3 latches, and you can see that it is separate between left hand side and also right hand side. And we already know that the thrust reversal system is powered from hydraulic system. So it requires hydraulic system, and this on the 320 thrust reversal system has several defense lines to prevent thrust reversal deploy in flight, or any uncommanded thrust reversal deployment will be prevented by several defense lines, where it is EIU and subcomputer is the one that provide permission. How many blocker door? We got 4 of them on each engine. Next one, we got component location. So mostly component location, we able to see the ECU, ignition exciter on the right hand side, and then at the very bottom of the engine, we got alternator, which is used to provide power supply to the ECU. And here is a picture of the air starter. We got the air starter at the bottom, which is used to provide initial rotation for the engine starting. And we cover the component location on the left hand side. For example, we got the fuel pump and also HMU. And next one, we cover the air system, where the air system consists of compressor flow control and also turbine clearance control. The subsystem of compressor flow control is the VBV, variable bleed valve, and another subsystem is the variable stator wheel. So these two systems is to increase the engine stall margin, and turbine clearance control is divided into subsystem, which is low pressure active clearance control and also high pressure active clearance control. So these two subsystems is to increase the energy or efficiency of the engine by able to extract more air from the turbine by maintaining clearance between the turbine and also casing. And we already covered the oil tank, the oil system component, which is located on the left hand side, which is the oil tank. The loop unit can be found on the left hand side of the engine. And we cover the thrust reverser component. One of it is the shuttle valve located at the pylon, and hydraulic control unit located at the engine itself, but it is on the right hand side of the engine.
Sir, I have a question. What's the purpose of the shut-off valve?
So just now, if we look at the previous schematic diagram, the shuttle valve is provide hydraulic supply to the thrust reverser. So hydraulic supply, the thrust reverser is governed by side computer. Just now, if we reverse or we take a look at the previous slide, so from this slide, this is the hydraulic shuttle valve, the one that located at the pylon. So the side computer is the one that provides permission to the shuttle valve. Like I said, thrust reverser, in order for ECU control thrust reverser, it requires these two permissions. These two permissions is a defense line to prevent thrust reverser deployment in case to prevent uncommanded deployment or any deployment in flight, which is it requires permission from different parties, different components.
Does the SEC provide command to both engine independently or coming from single SEC?
Now the SEC, the set computer requires, set computer number 1 is required for both sides, left hand side and also right hand side thrust reverser. Set computer number 2 require left hand side, set computer number 3 require right hand side. So it involves to deploy both thrust reverser, it involves 3 computers. Number 1 is set computer number 1 is mandatory.
How many SEC we have in one aircraft?
Altogether, we got 3 set computer, which is the primary purpose is to control flight characteristic. But the secondary function of this set computer is also to provide permission for the thrust reverser. Okay. So these two give permission, then only the issue able to control thrust reverser. Next one, oh, we already covered this. Component location. This component location. This is a picture of hydraulic control unit just now. This is the one that controlled by the ECU to deploy thrust reverser. And next, we have done the recap for component location. We are now moving to the engine description and operation. For the recap, we know that the engine has several variants, and the variant is according to the thrust rating, which is numbered from 1 to 9. So the variant from 1 to 9 representing a different engine thrust. If you have 5B3 model, then you will get 33,000 pound thrust. So this one is mostly used on 321, A321. If you have 5B4 engine, then the thrust rating will have 27,000 pound thrust. And it got some other parameter, for example, like the bypass ratio, depending on the variant that you have.
Which the most variant is mostly used in A320 series?
Mostly the airline use 5B4 engine and 5B6 engine. In case the airline require to have powerful engine, maybe due to the extra passenger, extra cargo, and they are operating at somewhere at the hot area country, for example like Middle East, mostly they require higher engine rating. For example like 5B2 engine, which is the 31,000 pound thrust, is considered high power. Same goes to 33,000 pound thrust, 5B3 considered high power. Like Asian they would like to use 27,000 pound thrust or 23,500 pound thrust, which is sufficient for our usage. Because if you are operating at the Middle East a very hot country, the engine thrust is reduced. So you cannot carry more passenger, you cannot carry more loads. You have to reduce load. So, but the airline don't want to reduce the load, they want to carry more passengers. So they require higher thrust rating in order to get the aircraft to off. So the higher thrust rating is much more preferable on hot countries, or if you are operating at hot countries. For example, like Asia is operating within Asian region. They are not going to somewhere in the Middle East, so there is not necessary for them to use higher thrust rating. So this is what being offered by Airbus. And then let's do recap regarding the turbine operation. So turbine operation consists of several main section. You guys remember how many stages of the booster?
9 stages.
Is it correct? 9 stages?
5 stages.
How about Mr. Azlan?
Is it 5?
Yeah, it is a 5 stages.
Oh.
So it consists of 5 stages, and we got primary airflow, and which one that provide highest thrust to propel the engine forward. What is coming from?
The fan.
Coming from the fan, which is about 80% thrust generated from the fan. And the fan is driven by how many stages low pressure turbine?
4 stages.
4 stages. 4 stages of the low pressure turbine. So you can see that this is the one that, since the fan is very large, you got more exact energy from the low pressure turbine. You provide rotation via a single shaft, long shaft here, and this is where the thrust mostly being produced by the fan, which is 80%. And we already covered engine bearing. So the shaft that just now is supported by several bearing, and HP shaft is supported. HP shaft is supported by bearing number 3 and bearing number 4. You guys remember what is a bearing number 3 configuration?
Ball bearing.
It's a ball bearing. Basically, it is a combination of ball bearing and also roller bearing. So ball bearing is the main purpose of ball bearing? Anybody? Why they design ball bearing configuration for?
Transmit thrust.
Yeah, to transmit thrust. Basically, ball bearing is used to take up forward thrust. And how about the LP shaft? LP shaft is supported from which bearing?
1, 2, and 5.
1, 2, and 5. Okay. And the bearing number 1, 2, and bearing number 3. Where can we find this the sum? Now, where does this bearing is housed?
The forward
The
sum.
forward sum.
Yeah, forward sum. So forward sum is the one that provide housing for these 3 bearings. The other bearing, which is bearing number 4 and 5, is housed within the aft sum. And this one we already covered. The air seal is used to provide oil sealing for the forward sum as well as aft sum, and then air is vented from the loop unit. Air is vented to the center body through the exhaust via shaft, where we already covered that topic within this inside this schematic diagram, where air is vented to the exhaust. And the air compressor also used to provide oil sealing, or to keep the oil within the sump via this libering seal. So it requires air pressure. And then we cover the engine construction, the fan, the HPC, which is consists of 9 stages, 5 stages of booster. We already covered this. This is just to show you individual picture. And we cover the terminology of what does it mean by stall, and we already covered what does it mean by surge. Stall means a local effect due to one blade that is stalled, but if you have more blades, for example, more stages, in case all the stages are stalled, that means if there is a tendency to become surge. Normally it comes with the other indication fluctuate, and also it may cause a loud bang when surge.
Which one is worse? Sorry. Stall
Yeah.
or surge?
Which one there is?
Which one is worse?
Compared to stall, stall it may result in noticeable degraded in engine performance. But surge, the noticeable is very severe. It may cause the flight crew to shut down the engine due to the surge. For example, like especially during takeoff, if the engine surge, if you may hear a loud bang, the indication is fluctuate, so the engine become useless, become hopeless. So in order to avoid a worse situation, the flight crew maybe have to shut down the engine, depending on the flight crew decision. Because normally surge comes with loud bang, it comes with fluctuate indication, and also it may cause vibration. So vibration is something that we don't want during the flight. So flight crew may decide to shut down. While stall, it may cause noticeable degraded in performance. For example, pilot may feel slow acceleration or slow deceleration, or maybe the full power may be degraded power during the expected. Let's say we're supposed to have 90% N1, but they can only get 80% N1, so degraded in power. So that's the difference between store and search. Search is much more worse situation.
Excuse me. Can the search situation cause uncommanded in-flight shutdown?
The search, it may cause uncommanded in-flight shutdown, but it very seldom to happen because normally search is happen at high power. In-flight shutdown also can happen from high power to shutdown depending on the type of failure. But search normally the engine is forced to perform at high speed, high power, but the engine unable to compress the compressor, the air unable to be compressed, so it can cause surge. So to cause it to in-flight shutdown may, but no, in case it happened to me, is already very severe failure, very severe surge. Normally surge, in case engine surge, normally flight crew has to lower the engine thrust and maybe shut down. The shutdown may be due to the depend on the type of damage. Because surge can cause high EGT. So normally during takeoff, you got high power of the engine output. Whenever the engine surge, it causes high EGT. So whenever crew see this high EGT vibration, they lower the engine thrust. Once they lower the engine thrust, if everything looks normal, they maybe they continue the flight or they have to return back to base. But in case once they lower the engine thrust, still vibrates, still high EGT, they may be required to shut down the engine. So depending on the type of damage and depending on the flight crew decision to shut down or to let the engine run. Okay.
So just curious, from the passenger point of view, other than hearing the loud bang during the search, is there any visual indication, maybe a fire or smoke coming out from the engine?
Yeah, normally engine search, there is a possibility you have fire or smoke. But to tell you whether you will see fire or smoke, that's depending on type of damage. Sometimes surge is due to the bird injection or any FOD, large FOD injection. So FOD injection, in case the injection is passing through the secondary airflow where it bypass, normally less tendency to surge. But in case the injection goes to the core, this is where it goes to very severe surge. Normally core, it will cause fire, tail fire, it may cause loud bang, it may cause smoke coming out. Okay. Any other questions? Call and search?
No.
Alright, we already gone through the combustor. Combustor where is the fuel nozzle is housed, and combustor is providing gas expansion that provide turbine section to extract energy from the gas expansion. And we cover that the combustor consists, the flame within the combustor consists within the liner, inner and outer liner. Okay, we already covered the combustor, where you can see the air is used to provide the burning or the combustion, and also the air used to provide cooling, which is being passed through the liner. And then we already covered the HPT, which is consists of single stage, and LPT consists of 4 stages. So the 4 stages, we are able to see that the location of LPT, where you can find the cooling tube around the LPT casing. And then we cover the gearbox. There are many rotating devices around the gearbox. For example, like IDG, PMA, hydraulic pumps, loop unit, fuel pumps, as well as the starter. And then we cover the engine station number. There are several station number around the engine, and then some of the sensors which identify according to the station number. For example, in case any sensors located at this location, then it is normally being identified by PS3 or T3 sensor. So depending on the station number. And last topic is the boroscope port. There are many boroscope port this to allow facilities inspection to the core of the engine. Okay, so there are many facilities for boroscope in the booster, compressor, combustor, as well as turbine section. Okay. Any other question, guys?
No,
All good?
very good.
So I believe the engine basic principle as well as component location, it would be best to look at the engine itself. Normally we do have practical session. Look at the engine so that you can view much more better at the component as well as the engine system. You can find further detail during practical rather than looking into the picture only. But principal operation we already covered. Hopefully it will find you well within the system. So in case you have further more questions, you can always ask me, you can always email me, you can always talk to me during practical. Okay?
Okay.
Alright guys, thank you very much.
Thank you.